When you understand where the bulk of human activity is happening during the course of a day, then you also understand where your market opportunities might be. And the same applies for humanitarian use cases. If you know that human activity and proximity is a likely precondition for infectious disease transmission, for example, then if you want to put down preventative activities, you're going to focus on where human activity is highest and where people are going to be most likely congregating. And so as we're able to detect and represent back to individuals where human activity is most intensified during the course of a day, then people can make their decisions accordingly.
Hello everyone and welcome to Problem Solved, a Geoawesome podcast. I'm Muthu and I'm joined today by my co-host Alex.
Hi.
So in every episode, we want to highlight real-world problems and explore how geospatial technology is solving them, thereby ending with the problem solved. So if you're curious about the real-world impact of geospatial data and tools, you've come to the right place. And as it is customary, before we dive into the episode and understand how geospatial is making a positive impact, let's actually talk about the problem in the first place. So Alex, help us understand what is the problem that we're focusing on today.
The problem that we'll be discussing today is availability and reliability of highly accurate geodemographic data. This kind of data combines location with demographic details such as age, income, or lifestyle that helps to make informed decisions to businesses, governments, but also to, for example, humanitarian agencies. And based on this, they better understand the behavior of people and needs of people based on where they live. Well, this data is very critical, but unfortunately, the quality of this data is really bad, right? So very often this data is outdated, very often it's incomplete. And traditional data sources such as census data, for instance, they are very often difficult to obtain or unavailable, especially in places where you don't have a culture of collecting that sort of information. The good news is that today this problem can be solved, or at least partially solved. We'll discuss it today. And we'll be exploring those solutions with Ben Winters, who is the founder of Population Explorer and one of the, world's leading experts in geodemographic data. Thanks for joining us today. So maybe to kick things off, you can start with introducing yourself and introducing Population Explorer.
You bet. Thanks, Alex, and thanks, Muthu, for the introduction. And you're absolutely right. I think both in the private sector world and in the humanitarian or development sectors, accurate geospatially integrated demographic data is critical. You can imagine that in the either the humanitarian space or the private sector space, in order for you to bring the product or service that you've developed into the hands of the person who will be buying that or the beneficiary in the humanitarian space, you obviously need to know first and foremost where that person is located. So you could, when we say this to a lot of our clients, you could have the best. If you're a restaurant proprietor, for example, you could have the best pizza in the entire world. You know that you've come up with the absolute perfect recipe, but unless you find an individual first who's interested in buying a pizza or who is hungry for a pizza, you won't have any success in the business world. And this is the case, like I said, not just for the private sector, but also the humanitarian sector. when we're working with governments throughout Africa or Southeast Asia, they are very interested in knowing exactly where their vulnerable populations are located in communities that are particularly susceptible to infectious disease or water transmittable diseases, or gaps in the education system, for example. And unless they have a clear, consistent system for identifying where these populations are located, they're going to be really troubled with delivery systems. They won't be able to provide the services when and where they're needed the most. So it's a very critical question, understanding population distribution, and the answers, unfortunately, are not historically easy to come by. Census exercises, which are generally conducted on a country by country basis, go out once every 10 years or so, and they generally sample a small segment of the population, and then through a number of mathematical exercises, extrapolate those findings to larger segments of the population. And not only is that process expensive, but it's also difficult to retain the validity and accuracy over the course of the following 10-year period. So what we're trying to do as a company is bring reliable, frequently updated data sets across the entire globe for both private sector and humanitarian applications, so that people can easily identify their target populations and deliver either the goods or services or government programs that they need to in order to make sure that their beneficiaries are in receipt.
So that's quite a challenging problem in itself, right? Because census data, like you pointed out, depending upon the country, is usually done every decade. And I know that India, for example, last did it already more than a decade ago, and they are still making plans to create a new census, which, of course, is the most populous country in the world. And there are certain challenges that come with being the most populous country in the world. And I don't assume that your approach relies on going door to door and collecting this data. So you would have to, as a company, come up with a system that's much different from how governmental agencies do this. So let's maybe dive into how do you actually go about this and how do you solve this? And do you leverage tools like satellite data, satellite imagery, and other data sources that maybe we are not aware of today to update this demographic information? What makes your solution as Population Explorer stand out from the other traditional demographic data sets that we are aware of?
That's right. Yeah, great question, Mutu. And I think, in the GIS space, there are so many opportunities to innovate and create products and solutions that will meet certain needs. You have to sort of define your lane and stay in it. Otherwise, the requirements will be so vast that you'll quickly run out of resources to meet them. And we are very fortunate to have be a partner of many gridded demographic data providers that allow us to serve up data sets that are benefiting end users in ways that are more improved than census data sources. And one of them in particular is Landscan. Oak Ridge National Laboratories commission high resolution satellites that scan the globe multiple times per year. And those high resolution images that are produced from those scans then are fed into a number of different models that triangulate those data sets against other data sources, including census and other observational data sources, that will provide a foundation that allows the Landscan community, including Population Explorer, to then extrapolate where people will be located on a day-to-day basis. So bringing that down into very, very abbreviated terms and layman terms, we take high-resolution satellites and use those to observe where people are located across the world, and then we bring that information back through our software system, which is called Population Explorer, which allows people to see where those people are located. And so now when you have that question, you say to yourself, listen, I've developed a certain service or a product that is appropriate for, let's say, females that are aged between 25 and 29 years old. Show me where all the females aged between 25 and 29 are located across the world, so I know where to put my new locations to offer this service. We'll be able to do that. And we'll do that in a standardized way so that if you want to determine where a location might be best positioned to service that population in North America, South America, Europe, Africa, Southeast Asia, we'll give you a standardized data set that gives you that information.
So now, as a client of yours, potentially, I would ask the question, all right, so you may have a super highly accurate data for some countries in Europe or the US, right? But how do you actually validate this data in countries where you don't have census data, somewhere in Africa, for instance, right, or somewhere in Latin America? So this is the first question, the reliability of the data, and the second one is freshness, right? So how often do you update this data?
They're detecting light patterns, so they're able to see in general terms where human beings are living and moving and conducting their business, because as people move around and buy or sell or go to work or come home from work or whatever it might be, they're emitting light patterns when they're doing that. And we can detect those patterns from the space, and we're able to say back then through our application that with a certain level of confidence, we know that this many people are living in this area because we've seen these patterns remotely.
It's kind of fascinating to think about satellite imagery in terms of light patterns. I don't, at least as somebody who's been in the industry for a while, that's not the way I would have thought about satellite imagery. You know, we always think about it as either SAR data or multispectral, hyperspectral data. And if it's multispectral data, then you're thinking it in terms of pictures, in terms of what kind of snapshot of the world do I get at like 10 a.m. in the world. So maybe that's something, you know, perhaps you've already dived deep on the website, or is this something where we could, you know, go to Population Explorer and understand more about how this whole analysis works?
No, it's a great observation, and in fact, when you think about and you see Hollywood movies about this too, you know, CIA agents are using satellite imagery to detect the license plate of this bad person somewhere in the world, you know, and they're able to follow them, and it's that sort of photographic view of something that gives you the validation. I know that this is Alex because I've seen his picture from space, you know, that kind of thing. But also, if you're seeing Alex move somewhere, you're seeing light with that individual. And if Alex is driving to and from work in the morning or in the evening, you're seeing his headlights on his car. You're seeing the lights from his office turn on, or the lights from his house turn on. Those kinds of things. And so what we're saying to people is that in a particular marketplace, the number of population that we're showing you or what we're representing will be there is what we would call an ambient population, not necessarily what census would count, because when census goes out and they say to individuals, where do you live or where do you sleep? That person will say it's in this location over here. Now, they might go to that location to have their dinner and go to sleep, but they might spend 2/3 or 75% of their day in a different location where they're working and then going to the gymnasium and then having lunch and whatever else might, you know, their day might involve. And our data sets are showing you that activity. the ambient daytime population of that particular location. And from a private sector standpoint, and then from a development standpoint, where, for example, disease transmission might be most intense, those data sets are going to be really relevant for certain segments. When you understand where the bulk of human activity is happening during the course of a day, then you also understand where your market opportunities might be. So if you know that 90% of people are going to be in location A during the course of a day, of course, you aren't going to offer your product or service in location B during that same day. You're going to go over to location A because you know that that's where the bulk of humanity is operating. And the same applies for humanitarian use cases. If you know that human activity and proximity is a likely precondition for infectious disease transmission, for example, then if you want to put down preventative activities, you're going to focus on where human activity is highest and where people are going to be most likely congregating. And so as we're able to detect and represent back to individuals where human activity is most intensified during the course of a day, then people can make their decisions accordingly. And in fact, we had one example. This was interesting. We've worked with FedEx in the past to help them locate new retail operations throughout the Americas. And there's another logistics operator very similar to FedEx who has recently signed on to Population Explorer, and they had drawn a catchment area in Western Washington in the United States to place a new retail location. And when they were looking at census data, the census indicated that only, I can't remember the precise numbers, but it was something like the census indicated only 25,000 people lived in that area. And again, census is telling you where people are sleeping. So you finished your day, you're going home, you're making your meal, you're sleeping. That's what census shows you. Our system was showing them that over 250,000 people were in that area because during the daytime activity, when markets were open and people were going to work and restaurants and grocery stores and gymnasiums and fitness centers and whatever else, that's where they were all congregating. And that's sort of the power and the unique insights that you get in a remote sensed application like what Population Explorer is offering.
Wow, that's really amazing because it's 10 times the difference. I mean, we're talking about 250,000 versus 25,000.
So this is already pretty amazing and exciting, but let's not stop here. Looking ahead, what is that the next big thing in the population measurements and reporting, right? So what are you guys working on, and also perhaps what is the role of AI in the whole process? So basically, how do you see the future?
Oh, there's so many answers to that question. We could probably go on for hours. I mean, the first thing is that we've been able to crack the code of taking census data and aligning it with remote sensed imagery to understand the true distribution of human activity. That's really what we're getting after, so that people can make their market decisions, their humanitarian decisions accordingly and quickly. But we need more than that. There are more attributes that need to be disaggregated accordingly. For example, income data. So we know where people are now located during the days, but how much buying power do they have, for example, or how much do they lack? And that can be both a private sector opportunity and a humanitarian opportunity. That's one component that we're going to try and layer on. As we talk about human movement, we also want to talk about transport. So where are the major roadways and how are those connected between where people are sleeping and where they're conducting their market activity. That's going to be not only a marketing play, but a risk management play. There's all kinds of axes that we can explore in there. So I think those things are important in terms of the core data sets that we're offering. AI has such a wide range of incredible opportunities. It's hard to sort of narrow down into a few that are going to be most relevant to geospatial. One in particular is that we want to, as best as we can, remove agency from the process. So we want, rather than presenting our end users a series of potential query operators that they can select to understand the demographic distribution and where optimal markets are located, we want that to be a more conversational process. So being able to click, for example, a chat box and enter their questions manually. But one thing that we see as very promising from the chat GPT world and the large language models in general is that they make the process of encoding and decoding queries less technical. So we're lowering kind of the barriers to access. So rather than saying, I have this very, very precise question and I want a very precise answer, and you've already formulated the precision of your question to the degree that a Google query would give you the answer back that you're looking for, you can be more conversational about it and get around to the questions, and through a process of iteration, come to that precise point where you say, this is what I'm looking for, and this is how geospatial data can help me. Make that a large language model operation. And that requires a lot. There are a few key players in the industry that are working on that right now. We're one of them, where we're trying to be able to map geospatial data sets into these large language models so that when you and I log into the system and we don't know exactly how to ask the question that we're looking for, the system can curate that process for us and through conversation provide the outputs that we're looking for. So I think those are two big frontiers for GIS data. Number one, that the products become more diverse and more granular. And that's the task that's facing both income distribution and other demographic attributes, trying to leverage the light patterns that we're seeing from remote sensed imagery. And then also, even though Population Explorer, part of its mission is to ensure that the system is simple enough so that any user of any educational background can log in and determine where human activity is going to be the most intense in any corner of the world, really. We want to lower that bar even further. If I can just speak into a computer prompt or type into a computer prompt, then through that iteration process of Q&A that large language models enable, I can remove that agency contribution or requirement altogether and get the answers that I need from the data sets. So that's what we see as the future, really, in a lot of ways.
Yeah, it's quite a few things to process there. I think at the end of the day, it's kind of really interesting, even for a problem that has a huge impact across different sectors. You know, we're talking about government aid, we're talking about private industry. You brought about the example of FedEx. If you go on the Population Explorer website, you see McDonald's, you see Intel, you see NASA, you see quite a few well-known names that use your data. And it's also kind of really exciting to see what role satellite data plays, AI as well. Ben, before we go, there is one question that we absolutely love that we think is important to ask, considering the fact that the podcast is called Problem Solved. What is the one thing that you wish that the geospatial industry, that's us, understood better about its customers?
Their customers don't know anything about the geospatial industry. That's the one thing. There's no question about it. So many of the clients that we work with that end up having these really revelatory moments where they're saying, I never knew that this kind of information was available, or that this kind of support was available for the question that I had. The primary reason they weren't aware of that is because our industry, me included, did not do a good enough job of speaking to them in their language and understanding the problems that they had. And I did another podcast last week, and the host of that podcast asked me, what was one piece of advice you could give to aspiring GIS entrepreneurs? And I'll give them that. I'll give you the answer here that I gave him, and that was know your end user. Before you try to sell them anything, solution, product, it doesn't matter. Be able to recount for me exactly the problems that they're trying to solve during the day, the challenges that they face, why precisely those challenges are challenges. Sit in their shoes and pretend like you're responsible for the things that they're responsible for. And then if you've walked that out, you've played out that scenario multiple times with 10, 20, 30, 40 customers, you'll be able at the end of that to say, okay, this is something we can offer. This is something we can offer. And this is how we have to package it. This is the kind of knowledge management support we need to provide on the back end. This is how we have to engage them one-on-one with our account executives, or whatever that process looks like for you. The issue that I see more often than not is that not just, this is in the epidemiology space, engineering, everything, GIS, whatever it might be, is that people believe in their own right that the solution they have is worthwhile before they even begin to engage with the customer. I'm a GIS engineer. Of course I'm valuable. Of course I have something that's worthwhile. But your customer doesn't know anything about it. So the more time we spend in front of our end users and our clients, the more we'll be able to bridge that translation gap and be able to offer something that's valuable and worthwhile, and frankly, something that you can monetize over time. So that would be my quick answer.
So focus on a user, their experience and their problems, rather than the technology itself.
Yeah,
right.
That's right.
Ben, thanks so much for joining us today. I mean, I think that this was super interesting, and I've learned a lot, right? So I'm very interested in Earth observation data, but hearing about how you are using that sort of data to map the geodemographics of the world, I mean, this is really fascinating. So thanks again for joining us today, and thanks for our listeners for tuning in. Remember to subscribe to Problem Solve, the Geoawesome podcast. We hope to bring you regularly more stories about geospatial innovation, and see you next time.